Another type of question, a triangle. We are going to find the maximum area of right triangle whose hypotenuse is given. So it's a test prep question. Hypotenuse is given as 10. We don't know the other sides. We can apply Pythagorean theorem to solve this question. And when we write the equation, we should reduce the variables down to a single variable. So we write either x in terms of y or y in terms of x. You know what area of triangle, right triangle is 1 over 2 base times height. So in this equation, area equation, you are going to insert y, which is written in terms of x, and take its derivative. But taking derivative is taking time because there is radical. Since it involves radical, we need to equalize denominators and stuff. It is a lot of work. So I suggest using a fast way for this type of questions. So the fast way for this type is c squared over 4, where c is the hypotenuse. So our hypotenuse is 10. According to the fast way, 10 squared over 4, which will be 25. So this is how we find the area in just one step by memorizing the formula or the fast way, whatever you call it. Okay, what if it asks about base or the height? The formulas for base and the height are same, square root of c squared over 2 for both. There's just one ministry exam question about this type. Another type, check it out 3 in the book. Find the dimensions of rectangle having the greatest area that can be inscribed in a semicircle of radius r. So by using the same method in this question, we can form a right triangle here, use Pythagorean theorem, write x in terms of y or y in terms of x, and substitute it back in the area formula, take derivative. Again, since it involves radicals, we need a lot of simplification, so it takes time. I suggest using the fast way for this type of questions too. So what is the fast way? It's asking about dimensions. Finding dimensions according to the fast way is length is square root of 2r, width is r over square root of 2. In this question, r is given as r, no number is given, so this is the answer. There is one ministry exam question about this type. Next type, an isosceles triangle is inscribed in a circle whose either radius or diameter given. This is an exercise question, and there is one ministry exam question about this type. So when we try to solve it, we apply Pythagorean theorem again, like the previous questions, isolating x or the other unknown, putting it back in the area formula, taking derivative. Again, it involves radical. It takes a lot of time. See, just half the page is spent to solve this question. So we don't have that much time to answer the question. So I suggest using the fast way for this type too. So the fast way is the area of the triangle according to the fast way is 3 square root of 3r squared over 4. R is not given, diameter is given, which is 8. Radius is half of it, which is 4. Substitute 4. 4's will cancel. 4 times 3, 12 root of 3 will give you the area. Okay, for base and height also we have fast ways if it is needed. Okay, next question, which doesn't have a fast way. We need to solve it, but solution is very simple. Test prep 8. And there are 2 ministry questions asked about this type so far. The rectangle is bound by 2 parabolas. What's the maximum area of the rectangle? So let's say this width is y, the length is, let's divide this into 2. Let's say this is x, 2xy. We are looking for the maximum area. What's the maximum area? So in order to have the maximum area, our area derivative should be 0. So what is our area? Our area is 2xy. So we need to write x in terms of y or y in terms of x. So what is y first? So I can say, since y is the vertical distance between those two given functions, we can say y is the vertical distance between given functions. So vertical distance means we are just going to subtract the functions from each other, right? So the vertical distance is the upper function minus lower function. This will give you the vertical distance. The upper function is the upside down function, which has negative in front of x squared, 30 minus x squared, minus the lower function, 4x squared. So by subtracting those two functions, we get the vertical distance, which is y. So in this case, we have 30 minus 5x squared. I got y, so I can insert this back in the area formula, right? So area is equal to 2x multiplied by y, which can be rewritten as 30 minus 5x squared. Let me simplify it before take derivative. 60x minus 10x cubed. That's a. What we need is a prime. So take derivative, which becomes 60 minus 30x squared, which is supposed to be equal to 0. Let's bring one of them to the other side. 60 is 30x squared. Divide both sides by 30. X squared will be 2. By taking the square root of both sides, x is plus and minus square root of 2. What is y? I need y too, right? So my y will be, since it is, what was it? Y was here. 30 minus 5x squared, which is square root of 2 squared. That will give me 5 times 2, 10. 30 minus 10, 20. So I know x, I know y, and I can find the area. So area is equal to 2 times x, square root of 2, times, since we are talking about side length, we won't use negative, times y, which is 20. So 20 times 2, 40 root of 2. If there is no unit given, so we will just say 40 root of 2. Okay, it is pretty simple if you just know the idea of finding the vertical distance. The rest is simple. All right, let's continue with the other type of optimization question, a cylinder question. A cylinder that's inscribed in a sphere of radius square root of 3. Find the height and the radius of the cylinder so that its volume is maximum. It's an exercise question and came in Wizari once. So we have to know the formula of volume of cylinder, right? What was the volume of sphere formula? Pi r squared h. We have two unknowns. To write them in terms of each other, we have to come up with an equation to link them together. I see a right triangle here. I have r here, square root of here, 3 here as hypotenuse. This is the center, so it will divide this height into 2. So I can say this is h over 2. So I can set this equation by using Pythagorean theorem, which says h over 2 squared plus r squared equals sum of the squares of the short legs are equal to square of the hypotenuse. So h squared over 4 plus r squared equals 3. I need h in terms of r or r in terms of h. It doesn't matter. Let me isolate r. So when I bring h squared to the other side, r squared will be 3 minus h squared over 4. I don't need r alone. I need r squared because in the formula we have r squared. So let's substitute this back in the formula. Volume is equal to pi r squared, which is 3 minus h squared over 4 times h. And let me distribute this, get it in simplest form. 3h minus h cubed over 4. Now I'm ready to take derivative. So let's take derivative of this volume. Since it is easy, I didn't apply the fast way. Volume prime, pi is the coefficient space. Derivative of 3h is 3 minus derivative of this is 3h squared over 4, which is supposed to be 0. So divide both sides by pi and bring negative 3h squared over 4 to the other side. 3 will be 3h squared over 4. You can cancel 3's and cross multiply. 4 is equal to h squared, then h is equal to 2. I know h, I got one of the dimensions. I need the other one. What was the other one? The other one is r. So r squared was equal to 3 minus h squared over 4. H is 2, 2 squared over 4. 2 squared 4, 4 over 4. 1, 3 minus 1, 2. R squared is 2, then r is square root of 2. So I got the dimensions. My height is 2, our radius is square root of 2. Solution of this type is pretty simple. If you want to use the fast way, it is radius being square root 2 over 3r, height being 2r over square root of 3. You get the same answer. Okay. Last type of optimization question in the book, exercise 11, and a ministry question. It has two parts. Two functions are given. It's asking about the vertical distance between the functions. In one of the questions, we talked about what vertical distance was. It was the upper function minus lower function. The figure is already given. So the upper function is 1 over 2x squared. Lower function is 1 over 16x to the fourth minus 1 over 2x squared. Make sure you are putting the function inside parentheses, so which will give you 1 over 2x squared minus minus plus 1 over 2x squared, x squared minus 1 over 16 x to the fourth. I got the vertical distance. I am done with the first part. What about the second part? Second part is asking about the value of x where the vertical distance is maximum. Again, we are talking about derivative. Derivative of what? Derivative of distance. So we need derivative of distance being 0. So take the derivative of the distance that we found in the previous part. Derivative of x squared 2x minus 1 over 16. Derivative of x to the fourth is 4x cubed, which is supposed to be 0. Let's do some simplification. 2x minus x cubed over 4 is 0. Let's bring this one to the other side. 2x is x cubed over 4. Cross multiply. Or just take x as a common factor. This is easier, I think. So x is common. We have 2 minus x squared over 4, which is 0. So then apply zero product property. X is 0, or 2 minus x squared over 4 is 0. If this is equal to 0, then 2 is x squared over 4 when you send the second one to the other side. And cross multiply, 8 is equal to x squared. By taking square root of both sides, x will be plus and minus 2 root of 2. We are looking for the value of x where the vertical distance is maximum. We found 3 of them, but which one is true? Which one is true? When you look at the graph, at 0, there is no distance. At negative 2 root of 2, it's on the other side of these two graphs. So this number has nothing to do with these graphs. So our answer must be 2 square root of 2. Maybe somewhere here. Okay. So the answer is positive 2 root of 2 only. So we are done with optimization.